This is my RF45 style milling machine. These are Taiwanese machines resold by multiple suppliers. This one is badged as an AMA45 sold by Amadeal here in the UK, but they're all made with the same castings and are very similar. The quality can vary though. I've had this machine for several years now. I bought it second hand. It was quite new but hadn't been very well looked after by the previous owner. I got it for a bargain price though. It has a geared head with 6 speeds. The gearbox has always been fairly noisy, though recently I think it's been getting worse. The gearbox is oil filled, and I've also noticed it's developed a leak through the spindle. So the seals must be wearing out. I've never opened up this gearbox before, but I think now it's time to investigate the problems. The first thing to do is drain the oil. There's a plug located under the head. I'll refill it later with fresh oil. Next, I need to remove everything that's attached to the head casting, including some things I've added. I installed the Z scale for the digital readout behind the front cover. To do this, I had to add spacers to create more room behind the cover, and also extend the gear change levers. I think this is much neater. The scale mounts to what would be the quill depth stop, but I never used this anyway. Here we see the motor input shaft with small pinion at the bottom, the shaft that holds the high, medium and low gears. This is the selector arm. The gears which select between high speed range and low speed range came out attached to the top of the casting. The end of the shaft fits in this bearing. And this is the high range, low range selector arm. The spindle drive spline fits through here. You can see the oil seals. This part also came out attached to the top of the casting. All of the bearings feel smooth without excessive play, except for this one on the end of the motor input shaft. This feels rough and sticks. Since I've torn the head apart, I'll replace all of the bearings with good quality ones anyway. The gear change clusters are keyed to the shafts and slide up and down to change speed. The high-low range cluster has a lot of play. The key seems to be loose in its slot. This might be the cause of some of the noise. The other sliding gear cluster has hardly any play. These are the seals that are meant to stop oil going down the spindle. There are 2 of them, one on top of the other. The lip on the top one looks worn and damaged. I'll replace both of these as well. There's one bearing in the bottom of the gearbox that won't come out easily. It's pressed flush with the surface and there's no way to get behind it to knock it out. I can't really heat up the entire casting either to try and break it free. Here's how to get it out. Just add grease. Then, with a rod that's a close fit inside the bearing, if grease alone doesn't work, adding bits of paper towel can help. Fortunately, the keyway for the sliding gear cluster looks okay. I could mill a new one, only I no longer have a milling machine. The key itself is damaged. I have some key steel in this size, and it's a simple job to make a new one. There were 8 bearings in 3 sizes, though I think some of these machines have different types fitted. I replaced all of these with good quality branded bearings, which wasn't all that expensive, from about £3 to £6 sterling per bearing. I'm going to install the bearings as they came out. I turned this rod to push on the outer race to press this bearing back into the casting. The other bearings I'll install with my small hydraulic press. Before reassembling everything, I place a small magnet in the bottom of the gearbox to collect any metal particles. I'll also clean off the old sealant and renew it. I forgot to record it beforehand, but there's now much less backlash in the whole gear train. I'm refilling the head with the recommended grade of gear oil. I don't know if this will come across on video, but it sounds significantly quieter and smoother than before.